Hello from whatever time you're watching. I hope you're having a good day. Today we are going to cover lesson 1.3, talking about perpendicular bisectors and constructing them. So let me share my screen so you are able to see that and read that clearly. So there we go. Okay. So this section, like I said, is on constructing perpendicular bisectors. If you are following along in your book, again, should have that with you. We're working on pages 19 through 22. And if you still haven't done your homework, remember that is on pages, let me make that just slightly clearer, 23 through 25. So please make sure you complete that after the lesson. So our I can statements for this lesson is I can construct a perpendicular bisector, and I understand what is special about the set of points equidistant from two given points. And remember, just in case you're forgetting the word equidistant, I know that may be a less familiar word sometimes, as you guys remembered in class. Hey, equidistant sounds like equal distance, and that's very much what it means. It's just two words smashed together. So as we continue this, let's look at some key vocabulary. So remember, a circle, we covered that in section 1. Circle of radius r with the center O. Again, it's a set of all points that are r units away from that center O. To draw a circle with a radius of 3, you would set a compass to 3 units and then just draw that circle. A conjecture, this is one of our new vocab words for this unit. A conjecture, or for this lesson, sorry. A conjecture is a reasonable guess that you are trying to either prove or disprove. A conjecture is very much like a hypothesis. But it says, say, a hypothesis in math. In geometry, we are going to put forth a conjecture. So in math, what we are doing will either be provable or unprovable. So when we look at something like the Pythagorean theorem, there are hundreds of ways to prove that will always hold true. So the conjecture would be a squared plus b squared equals c squared in any right triangle. Whereas like a hypothesis in science, you will do the scientific method where you experiment, collect data, draw a conclusion, and see how that compares. Science tends to have a mountain of evidence behind what the facts are, whereas math will have logical reasoning behind our conjectures to prove them true, but very similar idea to a hypothesis in science. Line segment is the set of all points on a line between two endpoints. Again, we covered that in the first section. The next thing we're going to talk about are a set of parallel lines. Remember, parallel lines, as we expressed a lot of good ideas in class. The big thing is two lines that don't intersect are parallel. I know some people in class brought up, oh, they have the same slope or they're slanted the same. Some people said they're always the same distance apart. We had various ideas come out, all pointing to this exact definition. Just remember, parallel lines do not intersect. And again, as a point of clarity, they have the second sentence here saying two line segments are considered parallel if you extended them on forever as lines and they still did not intersect. The next term we have, stop listening to me. Sorry, my watch bugged me. Is perpendicular bisector. So when we say two lines are perpendicular, we know they meet at a right angle or 90 degrees. Remember, we can use the term, 90-degree angle and right angle interchangeably. But it doesn't, oh, sorry, lost my words there for a second. A perpendicular bisector has to meet at a right angle, and it has to split it into two equal parts. So if I were to add a point, let's call this E, to this diagram, I could say AE is equal to EB, as those two segments are congruent, and we do see the marker for this being a right angle on there. So excuse me. So now moving on to the human perpendicular bisector. I'm not going to re-record this. We did this in class, and we saw how good of a job we could do. So just a refresher of what we did is we created a perpendicular bisector. Remember, we had one student stand on one endpoint and another hold a tape measure. We used that to make sure our distances were set the same. And they walked around and we saw they created an arc. Then we flipped to the other side of that line segment with another student walking around, they made an arc. Once we did that, where it looks like the arcs connected, we drew a line through that. So that is how we created a perpendicular bisector. So let's watch that in action right now. So I'm going to do that on Desmos. So I'm doing this digitally. We will see me do it by hand before the end of this recording, but I want to focus on the digital, and the link will be available with this as well. So first thing we're going to do is just create some random line segment. We can't bisect a line segment if there's no line segment to bisect. So now what I am going to do is well, let's label those points. I like having labels on my points. So let's select that, turn on the label A there, select this one, turn on that label, come on. That one's B. And now let's draw a circle. So remember, if you're using a compass, you are just going to set your compass, put it on point A, and gently spin it around. And I'll talk again about tips for using these compasses that were provided. So I'm going to go A to that line here. I just need to make sure I'm over halfway, because as we observe with the human perpendicular bisector, we noticed that we needed to be more than halfway, so we got overlap happening. So I don't have to be perfect. I just need to estimate where more than halfway is. And it looks like I've done that going from A to where the circle intersects the line. So what I'm going to do, now this is a step you don't have to do if you're doing this by hand, but if you are doing this construction on Desmos or GeoGebra, whichever one you're doing, you will need something to help you set the radius of your next circle. So what I'm going to do is I'm going to create a line segment between A and where the circle intersects. This way I can use that line segment, which is the radius of this circle, to create the radius of my other circle. So remember, to create a circle with the same radius, we go to More Tools and Compass. So now that I have the compass, it tells me choose a segment that will be the radius. So go click on the radius of the first circle. Notice it puts a green check mark there, so I know I'm good. Then it tells me choose a point that will be the center. That's going to be my point B. And there we go. We have our two arcs, or for in this case, full circles. Oftentimes, again, when you're using a compass, you are not going to make full circles here. Arcs that are about a semicircle will be good enough for what we need. Because what we really need here are now these two intersection points. So let's take a look at those that point here, that point here, and I'm going to label those points C and D. So this point up here will be C. This point down here will be D. Now I'm really close to being finished here. All I have to do is draw a line between C and D. And this line, since everything was done correctly with this, since both these circles are identical, it will not only keep me perpendicular to this line, but it evenly splits line segment AB. And we'll confirm that in a second. So let's go C to D. There's that line. I'm going to call where that crosses here. You know what? I'm going to be fancier with my naming. And since this is the midpoint, I'm going to call this point. And when I turn on the label, it automatically goes to E because it likes the letter in alphabetical order. But since that is the midpoint, I'm going to be fancier with my label and call that M for midpoint. So now this looks good. Let's confirm that mathematically we did correctly bisect this. So AM should be equal to MB, and we should see angle CMB, or whichever one we choose. We could do AMC, AMD, DMB. Doesn't matter, but we'll show that that is indeed a right angle. So to do this, what I'm going to do is I'm going to get a segment that goes from A to M. Now do a segment that goes from M to B. And now what I'm going to do with those, well, I did not get my A to M segment. Sorry about that. A to M. There we go. Is when you label a line segment, let's hide that line segment that I have made to help show A or the radius of circle A. I'm going to hide that right now. So now when I click here, there we go. It's selecting A to M. When I label a line segment, it is going to label it with its length. Again, now I'm going to do the same thing from M to B, label that, and we get the length as well. We get both are 3.46. So made it into two equal parts. Let's take a look at that angle. I'm just going to go from C to M to B. And indeed, that gives me that 90-degree marker. It is indeed a right angle. Now, here's the really cool part about a correctly done construction. If you do a construction correctly, it should be what we call unbreakable. No matter what we do to it, it will not budge from splitting AB in half and being perpendicular to it. So I can move point A all around, and no matter where I stop, we get that right angle. I am sorry how choppy that was. And we see that those sides are the same. Again, I can move B. Again, in doing so, we see no matter where I stop, that's the case. Now, D and C will not do much if I try to move them because those are very static points defined by those circles. So the only way to move them is to move the radius of the circle. If I click like on point M, again, since that's defined on C and D, which were already made static by the circle, again, we can't do anything there. So I will save this. So again, I can do save. I will call this perpendicular bisector. Make sure I spell that right. Okay. 1.3 constructing perpendicular. It's not our practice. This is just an example. Okay, so please, I hope the noise isn't too bad on this video. If it is, please let me know and we'll work on reshooting later. This is just a lot to take the time to reshoot this. So now that I have that saved, I can copy this URL here, copy, and I'm going to actually put this right here underneath, and paste. Let's go with, oh, there, I want to put it down here. Actually, let's undo that. This way I can get rid of where it's not as nice looking. And paste. So this URL will be available to you in the notes. We'll make sure to hyperlink that later, but if you go there, you'll be able to see the exact thing I just made. So let me change the color of that so it stands out more to you guys when you look back at the notes. Actually, let's see. Very quickly, let's see. Can I hyperlink this? Sorry for this time. No, I can't do that super fast. So let's just change that to blue and underline just so it looks like a link. I will make sure that is hyperlinked in the PDF that is available to you guys. Next thing we want to look at is a perpendicular bisector. Again, we looked at that definition already. Here we have two examples of things that are not perpendicular bisectors. As you look at this first example here, A to B does appear that it's cut in half by C, but line ED does not create a right angle with it. So this would not be a perpendicular bisector. So that's a no-go for us. Over here, it does appear line IJ is perpendicular to line FG. However, if I look at line segment FG, F to H is visibly longer than H to G. So this would not make this a perpendicular bisector. So that's a no on that as well. So remember, both scenarios have to be fulfilled. It has to be perpendicular and it has to pass through the midpoint. So on this slide, this was an example of a perpendicular bisector, just a little space for you to practice on there. I believe this was page 21 of your book. So you can again practice right there, making a perpendicular bisector like we did on Desmos. You can do it by hand with a compass. We'll go over those hand steps in a second, or you can do it like I did here digitally. So now, or as we get to the end of this, so how do we know that a point was the same distance away from two given points without measuring with a ruler? So we do that by setting the radius of the compass. If we do not change the radius of the compass, that means it will keep creating congruent circles. So they're circles that are equal. So we use a compass to guarantee that. So what exactly is a circle? Well, as we define, the circle is a set of all points R away from the center, where R is the radius. How do we use this to reason, or how do we use circles to reason about distance? Well, whenever we draw circles, if we know what the radius is, we know all points around the circle have to be that same distance away from the center. So regardless of where we draw an extra line there, we know that to be fact. So some quick things on notation. Looking down at this diagram, we know that line segment AB is perpendicular. Let me scroll so we can see a little more of the bottom of that. is perpendicular to CD. We use that little upside down capital T to signify perpendicular. We also know A to E is congruent to E to B. And we know that the angle AEC is 90 degrees. So the last thing I want to really cover is this. This is our exit ticket. I know class was a little shorter, so we didn't fully have time to get that. If we had 71 minutes instead of the 58 minutes we had today, we would have had time to get to this in all classes. So let's read the scenario that I'm going to go off the board to do this by hand. So imagine you must cross the hallway while staying an equal distance from the lasers. If you get closer to one laser than the other, it will blast you. So use the compass and a straight edge to draw a safe pathway. So no matter what, I can't move closer to laser 1 or laser 2. I have to stay in the middle. So let me stop sharing. So to stay in the middle, we get some really good information. So share. So it is important if we are trying to stay in the middle, that what we need to do is find where the middle is. Well, this whole unit or lesson has been about perpendicular bisectors. So our goal is to cut the middle between laser 1 and 2. So if I can draw a line that stays in the middle, that is perpendicular to where the 2 lasers are, I should be good. So let me get my camera situated. So hopefully we can see this pretty good. Sorry, just trying to find something to prop the camera up so we can see nicely what's going on the paper. Okay. So trying to arrange it so it is as nice as possible for you guys. So I want to make a perpendicular bisector here. The first thing is I'm going to see where that path between laser 1 and laser 2 is. I can just draw a straight line between them like so. So if I could remain perpendicular to that, that keeps me equidistant, between lasers 1 and 2, assuming I stay in the middle between them. So our goal here will be to make a perpendicular bisector. So first thing I need to do here is I need to make sure I'm more than halfway. So I'm just going to go there. Okay, that's more than halfway. And I'm just going to draw an arc. Now, one technique I've just found very helpful for drawing an arc with these is instead of spinning it around here, I actually just gently spin the side where the metal point is for the center. I'm finding right away that it's helping me move or helping the compass move less. Now, if your compass moves, just take it back to where you started and reset the distance. So please, we need to be gentle with these. This is why I'm giving you the option to do it with the compass or do it digitally so we can get practice with both and use the tool that works best for us. So what works best for you might not be what works best for somebody else, and that's okay. Now, one thing I do want to point out is I just moved my position around the paper. I'm keeping the paper static for the video, but oftentimes it can be very helpful to move and rotate the paper as you make constructions to what feels most comfortable for you. So now I was at laser 1. Let's double check this hasn't moved. Yep, it's good. Now I go to laser 2, and I'm going to again draw an arc, just nice and gentle, not using too much pressure. And there we go. Now I have my 2 arcs. I know they're a little light. Now remember, with the construction, you are not going to hand draw them. If you do a construction where you are attempting to hand draw circles and arcs, it is wrong. You will not have the accuracy you need to do it correctly. So trying to hand draw it is wrong. You must be using a compass and a straight edge. So now that I did that, I can draw this path. And hey, if you look where you are standing, actually lines up very well with this perpendicular bisector. So no matter where I am on this singular line, I'm going to keep the same distance from laser 1 to laser 2. So if we do a very quick thing, I'll just put a random point on here to demonstrate what I'm saying. So going from laser 2 to that one point is about 3/4 of an inch. That point to laser 1, again, 3/4 of an inch. If I put another random one here, again, laser 2 to that point is about 1 inch. Laser 1 to that point, again, 1 inch. So following that perpendicular bisector keeps us equidistant from those 2 points. So that is what we have for the lesson. I hope that you found this helpful. If you still have questions, please make sure you're asking them in class. Do not forget to attempt the homework, which we saw on the PowerPoint, was pages 23 to 25. Thanks for watching and have a great day.